Hey guys, I wanted to make a video going through all of the questions on the last quiz that covered confidence intervals. I did get quite a few emails, and normally I would talk about some commonly missed questions in class, but because we don't have that option, I did want to make a video. I thought it might be easier to make a video than just typing out a bunch of things. About explanations and things like that. I'm also going to kind of flip back and forth to highlight some of the pieces in the notes from chapter 8 that you might want to go back and look at for each of these problems. So keep in mind that my numbers are likely different than yours, but the context should be the same. The order also might not be the same. So this is the first question on mine when I pull up to view the quiz, but yours is likely in a different order. So just kind of keep that in mind. Also, the answer choices might be in a different order as well. So the first one, a 2015 survey of 400 randomly selected drivers reported that 20% of drivers never use their cruise control. A 95% confidence interval is given by low bound 0.161, upper bound 0.239. So part A is asking us to interpret the interval. Notice interval is underlined. So we talked about the difference between interpreting the confidence interval, meaning using those two numbers in your interpretation, versus interpreting what it means to be 95% confident. So that would be interpreting the level. So here I want to flip to chapter 8 notes. Let's see. So we talked about interpreting the interval and the level pretty far at the beginning of chapter 8. So this is number 4 in our notes. I think this is an 8.1. How do we interpret a confidence interval? So we want to make sure that we include 3 important parts here: the percent confident that you are, the numbers in the interval, the low bound and the high bound, and then also what is it that you're trying to make an inference about. So remember, we're trying to make a plausible range of values for which we think the true population parameter is in. So in this particular case, since this is a 95% confidence interval, and we're trying to figure out the true population proportion of drivers that never use their cruise control. So we want to say we are 95% confident that the true proportion of all drivers who never use their cruise control is between 0.161 and 0.239. So a couple of things about some of these other options. 95% of all random samples, 95% of all random samples. So here, this third one, 95% of all random samples will result in sample proportions between these two numbers. Well, think about that. Doesn't really make sense because every sample that we take is going to be different from this one, and these two numbers depend on just this one particular sample. So it wouldn't make sense to say that like 95% of every single sample that we could possibly take is going to end with these same two numbers. Same thing, same reason here. There's a 95% probability that the true proportion is between those. We did talk about the confidence level does not tell us a probability, because thinking about the true proportion of all drivers that never use their cruise control, that's a single number. That's population proportion P. Now, we don't know what it is, but it is a single number and it's fixed, meaning it's not going to change. That's the true population proportion. So that true population proportion is either in between these two numbers or it's not. So there's not a 95% chance. There's either a 100% chance or a 0% chance that that true population proportion is between those two numbers. We just don't know which one. This last one here, 95% of all random samples of 400 drivers chosen from the population will result in confidence intervals which contain 0.2. Again, this 0.2 is only particular to this one sample. So we don't want to take our one sample and say every other sample or 95% of all the other samples we could possibly take will look just like this one, because this is just one single sample. So our 95% confidence interval, we can interpret as we are 95% confident that the true proportion of all drivers who never use their cruise control is between those two numbers. If we did a different confidence interval, if we took a different sample of 400, we would likely get a p-hat different from 0.2, which means we would get a different confidence interval. So our interpretation would still be the exact same thing here. It's just then these two numbers would be different because our lower bound and our upper bound would be different if we took a different sample. So A is our correct answer there. So let's check that one off, or the first one there, for me at least. Part B, what is the margin of error for the given interval? So the margin of error, let's flip back here. So our first two questions, what is the general formula for a confidence interval? So remember, our confidence interval is made up of a sample statistic, and then we add and subtract our margin of error, and that gives us our low bound and our upper bound. So if we go backwards here, I already have my low bound and my upper bound, and I already have my sample statistic. So I just need to know, what did I add to 0.2 to give me my upper bound? What did I subtract from 0.2 to give me my lower bound? So if we do 0.239 minus our 0.2, because remember our 0.2 should be right in the middle here. If I do 0.239 minus 0.2, I'm going to get 0.039, or I could do 0.2 minus 0.161, and I would also get 0.039. So my answer here is 0.039. Part C, what would happen if we use the same data, that same sample of 400, but we wanted to create a 90% confidence interval instead of a 95% confidence interval? So notice this is a select all that apply. So let's think about our formula for a confidence interval for a proportion. So I'm going to flip over to our 8.2 notes where we actually had our symbolic formula here. So we have p hat plus or minus z star times our standard error. So I'm going to go ahead and copy that over, and then let's talk about each of those different parts. So if I used the exact same sample, what's my p hat? Well, we're given the p-hat in that particular sample was 0.2. So 0.2 is still my p-hat because this problem told us that we're using the same data. Plus or minus z star. Remember, that depends on our confidence level. So this is a z star critical value. A 95% confidence interval gives us a z star of 1.96. So 1.96 was used to calculate this 95% confidence interval, but we now want to do a 90% confidence interval. So 90% confidence interval, remember, we can always do this in StatCrunch, but a 90% confidence interval would give us a z star of 1.645. If we flip back to our notes again, we actually did that one. Number 8. So we use StatCrunch to find out this answer here. So we're looking for how far do I need to go out from the center to capture 90% of the observations, and that would be a z critical value of 1.645. So here, this would be 1.645. And then our standard error is the same because we're still using that same p-hat. So 0.2 times 0.8 divided by our sample size of 400. Now, you don't actually have to calculate all that, but you certainly could if you wanted some more concrete values to work with here. But let's think about some of these options. The new confidence interval would not be centered at 0.2. Well, we're using the same data. So if we're using the same data, then that tells us our p-hat is 0.2. So it would still be centered at 0.2. So let's go ahead and check off this guy. The new confidence interval would be centered at 0.2. Now let's talk about each of these two. So remember, the only difference now is our critical value here. So think about this picture over here. If I went from a 95% confidence interval to a 90% confidence interval, is my interval going to get wider or is it going to get more narrow? So think about here, we can actually see it in this picture. Here, I'm capturing less of the observations when I have a 90% confidence interval. And here, I'm capturing more of the observations. And that's because I'm going out farther here. I'm going out not as far for a 90% confidence interval. So here, we want to think about we're using a critical value that is smaller than the one we used before. So this is the one we used before. Now we're using 1.645. That means we are adding and subtracting less than we did before. So if we're adding and subtracting less than we did before, then our new confidence interval is going to be more narrow than it was before. The other two, these two down here, we've already answered both of those parts, so those wouldn't be correct. We do know that the interval would be centered at 0.2. We do know that the width would be more narrow. So that's the first one. The second one, for me at least, a luxury car manufacturer keeps detailed records on all current owners of their vehicles. The marketing director takes a random sample of 9 customer records and finds an average age of 50.8 and a standard deviation of 6.3 for owners. So here we are assuming that all conditions for inference were met, which is good because our sample size is pretty small, but we are assuming that all conditions were met. We want to know what is the lower limit for a 95% confidence interval for the average age of all owners of this luxury car. So I think what happened for a lot of you is that you likely made a very, very small error here in using a Z-star critical value. So you probably use 1.96 as your critical value, but remember, we are dealing with a population mean here. So we should be using a T-star critical value. So our formula, if we flip back to 8.3 notes, our confidence interval formula specific for means is x bar plus or minus t star times our standard deviation of the sample divided by the square root of our sample size. So I'm going to go ahead and copy that over. So we only need the lower limit. So I'm going to go ahead and erase my plus sign here. So my x bar is the 50.8 that we're given. So 50.8 minus, I'm going to just write t star for now. Our standard deviation of the sample is 6.3. And then our sample size was 9. So remember, this T star depends on degrees of freedom. So we do have to use the T calculator in StatCrunch to figure out that T star value. So when we do that, and I'm going to again flip back over to our Chapter 8 notes, we practice doing that on number 16. So we want to make sure that we use the T calculator and still using that between option. And we have to tell the T calculator what our degrees of freedom are. So because our sample size was 9, then we want to use degrees of freedom 8. Now notice here, Part B here does ask us for a T-star critical value for 95% confidence, but this would not be the right one for us because in this example, our sample size is 16. Our sample size for our problem in this quiz is 9. So our degrees of freedom would be different. It would be 8 instead of 15. Therefore, our T-star would be different as well. So you would have to find that in StatCrunch. But I'm going to let you guys go ahead and try that on your own using that piece of information from our notes in number 16. And then you can go back and check to make sure that you did get that right answer on your quiz or based on the key. So the last one, for this problem, please round your critical value to 3 decimal places. Major television networks want to know what percentage of NBA Finals viewers also plan to watch the show that airs after it. What is the minimum sample they need to survey to be within 4% of the true proportion at 99% confidence? So likely again with this one, we may have made that error of not rounding up to the next whole number. So again, I'm going to flip to 8.4 notes. 8.4 is where we talked about how big or small does our sample size need to be in order to achieve a particular margin of error? And that's exactly what this question is asking. What is the minimum sample size they need to achieve this particular margin of error at this particular level of confidence? So I'm going to flip over. This is talking about proportion. So we know we want to use this inequality here. I do think a lot of us were treating this as an equal sign for a while, hoping that all of you got my email, I think last week, at the end of last week, because I did keep getting some questions about one of the homework 9 questions that was asking you to solve for sample size. A lot of us were putting in a decimal answer, or we were using normal rounding procedures instead of rounding up. Now this says greater than or equal to, so we want to keep that in to account when we are using this formula to calculate what n should be. So I'm going to go ahead and copy this again, and I'm going to make sure that I write down my n is greater than or equal to. And then let's talk about what we can plug in here. So remember, our Z-star critical value comes from our confidence level. So again, you would want to take, or you would want to use the normal calculator in StatCrunch to find the 99% confidence, or to find the Z-star for 99% confidence. Now, I know this one by heart. The Z-star for 99% confidence is 2.576. So for this one, we would want to substitute in 2.576 as our Z-star. Now, when we substitute that in here, remember that's going to be squared, but because this whole quantity is squared, we can find that margin, or we'll plug in that margin of error as well. So we've got n is greater than or equal to 2.576 over margin of error. So the margin of error that we are asked to use is 4%. Within 4%. Within is why this thing is an inequality symbol. So within 4%, remember these are proportions, so we want to make sure we write that as a proportion. And then we've got that squared, and then p hat and q hat. So this is something else that we may have kind of skipped over in these notes or just kind of forgotten about, but it's right here on the same page. 21. How do you choose a value for p hat when solving for the sample size? So either use a proportion from a previous study if given, or use p hat equals 0.5. So in this particular problem, we were never given a previous or any information from a previous study. Therefore, we need to use 0.5 as our p hat, which also gives us 0.5 as our q hat. So I am actually going to calculate this really quickly. I probably should have done this ahead of time, but that's okay. You guys can fast forward or ignore me, or maybe you're not even watching, which is totally fine. So I'm going to go ahead and calculate this because I want to show you what the decimal answer is, and then talk about what we should round this to. Okay, so my answer here is 1,000. So I got 1,036.84. Okay. Now this one is nice for me in particular because if I were to round with normal rounding rules, I would round up anyways, but that's not always the case. So here, even if this were like 1,036.03, we still need to round up, and that's all because of this inequality symbol. Remember, we're looking for a number of people to survey. We can't survey a fraction of a person, but because this inequality says greater than or equal to, we want to make sure that we round up to the next whole number. So my answer here would be 1,037. That would be the smallest number of people I could survey to ensure that I got a margin of error that was within 4%. So keep in mind that we do need a whole number there, but also our formula has a greater than or equal to symbol in it, which requires us to round up to the next whole number. Okay, number 4 for me, in a random sample of 70 city dwellers, 26 said that they rode the subway regularly. Pause. We want to think about, are we talking about a proportion or are we talking about a mean? So is this a yes or no question, or are we measuring something with a numerical value? Well, 26 said they rode the subway regularly. That's a yes or no question. So out of 70, 26 said yes, which means we're dealing with a proportion here. So we want to keep that in mind because that's going to help us figure out which conditions we need to check. So Part A says, find the lower limit for a 90% confidence interval built using this data. So again, our confidence interval formula for a proportion, let me do this a little bit easier. Here we go. So we're going to take our formula from here. We know we're dealing with proportions. So we are going to take our formula from here, and we only want the lower limit. Yours may or may not say lower limit. Yours could say upper limit, but mine says lower, so I only want the subtraction sign. My p hat, remember, is my sample proportion. So my sample proportion, I'm not going to actually round this just yet. My sample proportion would be the 26 over 70. So that's my p hat minus my z star. So again, using the normal calculator, or 90% is a very common one, which is one we already figured out. So 1.645 is going to be our z star critical value. So 1.645 and then times our standard error. So again, this isn't going to be very pretty, but I'm going to write this in fractional form. I suggest doing this just so that you're not rounding and rounding and rounding and rounding and rounding all over again, because the more you round, the farther you get from the correct answer. So this is what we would do in order to get that lower bound. Let's see, if I calculate all of that, I should get 0.276 is my answer. Again, yours is likely different. Part B, so I know that this is probably our least favorite question or type of question. What conditions are satisfied for constructing this interval? So what I noticed on the few emails I did receive and on the few quizzes I did check, what I noticed was a lot of students chose this answer here. The population should be approximately normal. So we have to be really, really careful here. So think about what question we're asking the population. We're asking the population a yes or no question. Do you ride the subway regularly? That's a yes, that's a no. So if we think about that, it's not even a quantitative variable, and it can't be normal because it's not a quantitative variable. So only distributions of quantitative variables can be normal. So thinking about what this population would look like, well, we have a bar graph. We have a bar for yes, we have a bar for no. So yes and no. That's what it would look like for our population, as well as our sample of 70. Now these bars would probably be different heights because our sample of 70 just had 26 yeses and the rest were no's. But this is essentially what that graph would look like for our population. This is never going to be normal. One, because it's just a yes or a no, and it's just a bar graph. So that's never going to be a normal distribution, because a normal distribution is for a continuous quantitative variable, and that is not what a yes or no question is. So that's one thing that I noticed here. So the population should be approximately normal is not a condition for a confidence interval for a proportion. But let's flip to our notes. Here they are. So large sample size. So the first one, large sample size, we need to make sure that our counts are at least 15. Our number of successes and failures are at least 15. So let's go ahead and check that guy off. So we do need that one. Let's go back here. We need to make sure the data come from a random sample, and we need to make sure that it's reasonable to assume our observations are independent from one another. Notice it doesn't say anything about a normal population, and that's because the population can't be normal, because we're looking at just a bunch of yeses and a bunch of nos. Those can't be approximately normal. So we're looking at the sample size being randomly selected, and then we don't have anything here about independence. If that were an option, we would check that one, but that's not here. So those are the only two conditions out of these options that we would need to make sure are satisfied for constructing this interval. Letter C, would it be realistic to say that more than 40% of residents in this city ride the subway regularly? So think about what our interval is. So our interval is a range of plausible values for the true population parameter. So my range of plausible values goes from 0.276, excuse me, to some number, right? So I could certainly calculate that upper bound if I wanted to, but there are values in this range that are less than 40%. So it's not realistic to say that more than 40% of residents in this city ride the subway regularly, because there are numbers in this range that are less than 40%, which means those numbers, those values, could be the true population proportion. So our answer would be no, because the interval is not entirely above 40%. Our very last question. Suppose we take a random sample of 102 individuals from a population. When we construct a 95% confidence interval and interpret it by saying that we are 95% confident that the true average lies inside the interval, what do we really mean by the phrase 95% confident? So this is asking us to interpret the level. So the very first question, I think, on the one that we just went over, or for this quiz, we were interpreting the interval, meaning we wanted to make sure we talked about the lower bound and the upper bound. We don't even have the lower bound and the upper bound here. And this question is asking for us to interpret the level. So let's flip back. This was at the very beginning of chapter 8. What does it mean to interpret the level? So right after we interpreted the interval, we interpreted the level. So the level is all about the method that we're doing. So you have to keep in mind that we only are taking one random sample and constructing one confidence interval. But if somebody else took a different sample, they would likely get a different sample statistic and then also get a different interval, a lower bound and an upper bound. Those would be different numbers. If somebody else took a different random sample, they would get a different confidence interval. So our 95% confidence, or the level, is all about the method that we're using. So the method that we're using works, quote unquote, about 95% of the time. What do I mean by works? Well, I mean it captures the true population proportion about 95% of the time. So if you remember way back when, this was before spring break, so quite some time ago, we looked at this applet, and I do encourage you to take a look. I did link the applet to our notes to take a look at this applet, but I did take a little screenshot over here. All these green ones here captured the true population proportion. These red ones did not. So we want to think about the confidence level as a long run capture rate. So thinking about if we were to do this over and over and over and over again, then about 95% of the confidence intervals that we've constructed should capture the population parameter. So looking at our options here, 95% of all random samples of size 102 from this population will result in confidence intervals that contain the population proportion. So this one is going to be our correct answer. Let's talk about some of these other ones and why they aren't correct. So the first one, we are 95% confident that the average of another random sample of size 102 will fall between the lower and upper bounds. So again, this is wrong for the same reason we talked about some of those other ones being wrong. This is saying that we think this other random sample will also look just like the one we just did. And that doesn't make sense because these are random samples, right? So we want to make sure that we aren't thinking that this one random sample tells us everything about all of the other random samples, because they're random and they're different and they're going to give us different estimates. The third one here, the probability that the particular interval we build contains the parameter is 0.95. Again, once we have our confidence interval, that lower bound and our upper bound, that p is either in there or not. We just don't know which one because we don't actually know what this value is, but it is fixed. So that p is either in there, so then that probability would be 100%, or that p is not in there, and that would be a 0% chance. There's nothing in between. It's either 0% chance or 100% chance. We just don't actually know which one. The last one, 95% of confidence intervals we construct from this population will have the same lower and upper bounds. Again, this is putting way too much emphasis on this one random sample that we took up here. It does not make sense to say that 95% of every single confidence interval we construct from this population will look just like the one that we just did. That doesn't make sense because, again, they are random samples and they're going to give us different estimates. So the 95% confidence or any confidence level is all about the method we're using to construct these intervals. If we were to do it over and over and over and over again, then about 95% of the time, we are going to capture that population parameter. So 95% of the time, meaning 95% of these guys should be green, about 5% should be red. I know that was a really long video. I do appreciate if you stayed till the end. If you didn't, I totally understand. It was a very long video, but I'm hoping that this is helpful for a lot of you. Please feel free to email me with any further questions that you have, or if something still seems confusing or you still don't understand why something is the way that it is, feel free to email me. And as always, I'm happy to meet virtually one-on-one. If you'd like to wait until office hours on Thursday morning at 10:30, you can also do that.